Good morning, everybody. Can you hear me okay?
Yes.
I hear you got lots of fun with registration. So unfortunately, I'm not there because I had other pressing issues like saying hello to my granddaughter. So I'm here to talk about budget prototyping on FPGAs, and I only got sort of 8 to 10 minutes, so I'm going to do it very, very quickly. And then my colleague Bradley is around somewhere with this lovely piece of board as well, so you can go and ask him about non-technical details, and I can then answer the technical details. I'm still around. So just 2 seconds about Sundance. So I've been running Sundance for what comes up to about 36 years, and we've been developing and building electronics ever since. We do everything internally. So we design our own boards and we build our own boards. It's all done on a shoestring operation, as much as that we are not set up to do thousands and thousands of boards. So we've done prototyping an FPGA since '93. So this board was our first board. And some of the numbers which are quite interesting to look at is the number of logic cells. So when I skip through the generations we're doing, you should just watch how the number of logic cells is going up. So this was done for an FPGA system, or a front-end system for PCs and for DSPs, etc., and customers implemented camera link interfaces or other video interfaces. So we skip forward about 2005. This was another platform we developed, which was used by TI for their DSP evaluation. So TI went from having a single core in a single processor until they want to have a multi-core. So this was a development platform which was simulating how TI could see multi-core DSPs. Got a very, very big FPGA in the middle, and that was what was handling all the intercommunication. So look at the cells. So 2012, we got involved in another project, and this is again using a fairly large FPGA. But the idea was to be able to combine and compare 2 different implementation of an ASIC effectively, and this was done for an EU project called FlexTiles. So the idea was to do different implementation in different part of the 2 different FPGAs that were all identical, and then see what was the best implementation. The idea for this was to do a 3D chip. So this was the prelude to what's happening now with people building like stackable chips. So this is a current board. It's a very, very low cost board. I don't think we managed to get one to show around today, but there's a few others which Bradley got on his desk. And so that's got a semi-large FPGA and lots of IOs. So this is one I think we did manage to bring along, and that's enabled a potential use case for designing your own carrier board, and then add a very, very big FPGA, and this one includes ARM cores as well. So the numbers of FPGA cells goes up and up. And this is the one I really want to talk about, because that's our new mega FPGA for prototyping. So we picked the largest microchip we could get hold of, and then we added we actually got 5 of them, but one of them is the master, and the other one is the 4 other ones are slave units. And the cost of this is about £18,000. And the reason why I mentioned that is because you'll see a little bit later that things can get very, very expensive. The concept of this is that we have 4 implementations of identical FPGAs, and then the idea is either that you can implement your prototyping on the different FPGAs, and you can try and swap them around, and you can compare them, or you can use them all together in one big FPGA block. And then it's controlled by the RISC-V core. So the multi-core version of the prototype has got sort of 5 RISC-Vs. And then these are just a slave. So these FPGAs are not as big as the one we can get from AMD and Altera, but they are a lot they're a lot less costly, and plus they also take a lot less power. The interconnectivity, so the master controller have a number of input outputs to give like kind of a PC lookalike, and it will run a Linux core as well. So you could do a Linux system beta on this as well. And then these are the five connectivities, and we have an awful lot of IOs. And there's both memories to the FPGAs, but there's also a number of IO boards which are connected to the FMC connectors. So the reason I mentioned pricing, because obviously what we're trying to do is, and these are our very, very big competitors. So what we're trying to do with this platform is enable small scale prototyping. It is not as listed of all these our competitors, which are incredible big systems and supported by lots and lots of engineers. But these platforms are designed for a low cost FPGA prototyping. That was my 8 minutes. Probably even less. So I'll leave you with that and questions if possible, or you can just carry on running the show because you're so much delayed. Thank you.